Hey everyone, welcome to this explainer. Okay, I want you to just take a second and think about something truly mind-bending. You lived a whole eventful life before the age of 3. You were born, you opened your eyes to the world, you heard your mother's voice, you tasted real food for the very first time, you took your first wobbly steps, and you spoke your very first word. And yet, you remember absolutely none of it, not a single moment. It's just a complete and total blank.
So where exactly did those first few years go? Most of us just kind of assume the answer is pretty straightforward, right? We think, well, my brain just wasn't ready yet, or I was way too young to hold on to those moments. But actually, scratch that. It's a massive misconception. Your baby brain was definitely not too weak to form memories. In fact, the real answer is far stranger than you'd probably expect. So let's dive right into this and uncover the truth.
There is this wild, foundational paradox at the heart of this mystery. As you can see right here, your baby brain wasn't failing to record your life. It was recording everything, literally everything. Your memories were actually there. You successfully stored the feeling of taking that first step and the exact sound of that first word. But something actively came in and destroyed them.
To put a scientific label on this little medical mystery, we call it infantile amnesia. Basically, it's the phenomenon where we adults just cannot retrieve memories from those first few years of life. Fun fact, it was actually Sigmund Freud who first put a name to this sort of missing persons case way back in 1905. But man, for decades, scientists were totally stumped by the actual physical mechanics of this amnesia.
Now you might be wondering, okay, how do we even know babies form memories if they literally can't speak to tell us? Well, back in the 1980s, psychologist Carolyn Rovi Collier ran this absolutely brilliant experiment at Rutgers University. She tied a little ribbon from a baby's ankle to a mobile hanging right above their crib. The babies quickly learned that kicking made the mobile move, and honestly, they loved it. When she brought those 2-month-old babies back days later, they started kicking immediately. They remembered. And astonishingly, 6-month-olds remember the trick for weeks. So the crucial takeaway here is this: infant brains absolutely do form, store, and recall memories.
Right, so if the memories are being formed, why on earth don't they stick around? Well, to figure that out, we've got to look at the neurobiology. Enter the first major biological suspect in our mystery, the hippocampus. Think of this little curved structure deep inside your brain as the absolute engine of memory. It's responsible for taking a lived experience, like a walk in the rain or a messy first birthday party, and encoding it into an episode that you can later replay in your mind.
Here's the catch, though. In a baby, that engine is basically still under construction. In us adults, the hippocampus works seamlessly with the prefrontal cortex to tag and store these memory episodes. But in infants, those physical connections are still actively being built. More specifically, there is a key region called the dentate gyrus, which acts as the gateway for new memories, and that specific wiring isn't fully complete until you're somewhere between ages 2 and 4. Because of that missing physical hardware, the infant brain can definitely form short-term memories, but it just can't move them into permanent long-term storage.
But wait, that structural delay is only half the story. There is this completely wild biological process that totally flipped how we understand childhood memory loss. It was discovered by neuroscientists in Toronto back in 2014. The process is called neurogenesis, which is the incredibly extraordinary rate of producing brand new neurons in the brain during your first few years of life. And I mean, this process is absolutely essential for wiring up the brain circuits you're going to use for your entire life.
So researchers Sheena Jocelyn and Paul Franklin had this hunch that all this rapid brain building might have a hidden cost, and they actually proved it using mice. Check this out. When they artificially sped up neurogenesis in adult mice, those adult mice actually started forgetting things they had previously learned. No way, right? And conversely, when they slowed down neurogenesis in infant mice, those babies held onto their memories much longer than normal. This was a real game changer. It proved that the very act of growing new brain cells is exactly what overwrites the existing memory circuits.
Which brings us to this brilliant analogy that really hits the nail on the head. Think of it like a house. The brain is building new rooms, but it's tearing down the old walls in the process. Your baby brain wasn't too weak to hold memories. It was just frantically renovating. Every single time a new neuron successfully integrated into an existing circuit, it violently disrupted the delicate connections that were already there, the very connections holding your earliest memories. The neurobiology basically wiped the slate clean just to make room for a bigger, better brain.
Okay, so the biological hard drive gets wiped. But from a developmental psychologist perspective, that's still only half the issue. Because to form a surviving memory, you have to ask one big question. Who is the main character?
To form an autobiographical memory, a memory where you can actually replay an event in your mind, you need a sense of self. You have to understand that you exist as a distinct person separate from the world around you. And babies, they just don't have that yet.
Let's break down how that sense of self actually emerges. Step 1. In your earliest days, memories are basically just raw sensory impressions, just random sounds, textures, and lights. Step 2. Somewhere around 18 to 24 months, boom, a sense of self finally shows up. Psychologists prove this with the classic mirror rouge test. Basically, if you sneak a red dot of makeup on a baby's nose and put them in front of a mirror, before 18 months, they treat the reflection like it's just some other baby. But after 18 months, they reach for their own nose. They recognize me. And then there's step 3, which changes the whole shebang. Language eventually comes in to structure the narrative.
That crucial third step relies entirely on this fantastic insight from developmental psychologist Catherine Nelson. She said, language gives memory a skeleton. Before you could speak, your experiences were just kind of floating around as raw impressions. Without words to organize them, those impressions had absolutely no framework to attach to. They were like water without a container. But once you start having conversations with adults about past events, like, hey, remember when we went to the park? Your ability to form lasting memories just skyrockets. And honestly, the power of language and storytelling is so intense that it literally alters brain recall across the entire globe. Take a look at this data from Cornell psychologist Chi Wong. The age of your earliest memory actually varies by culture. In Western cultures, where parents heavily narrate their kids' experiences, early memories start around age 3.5. But look at the Maori of New Zealand, a culture with an incredibly rich oral tradition of personal storytelling. Their first memories reach all the way back to age 2.5. Meanwhile, in some East Asian cultures that focus a bit less on early individual narratives, first memories tend to start closer to age 4. The culture you grow up in literally shapes how far back your mind can reach.
So, let's summarize exactly what happened to those earliest years of your life. It wasn't just one thing. It was basically a perfect storm of forgetting. First, your hippocampus wiring was incomplete. Second, that massive wave of neurogenesis literally bulldozed through your early memory circuits. Third, from a psychological standpoint, you had no continuous concept of self to anchor any of those experiences to. And finally, you lacked the language to give those fleeting experiences a skeleton that could survive into adulthood. It was biology and psychology combining all at once to create a universal black hole in human memory. Which leaves us with this final, kind of haunting thought. If you had no continuous sense of self back then, and if the physical brain that held your earliest experiences literally rewired itself beyond recognition by tearing down the old walls to build new ones, is the baby in your old childhood photos actually you? Or is it someone else entirely? Just someone who lived in the exact same body, but whose mind was disassembled and totally rebuilt, neuron by neuron, into the person you are today. I hope this explainer gave you a totally new perspective on your own mind. Keep asking those big questions, keep learning, and I'll see you next time.